So this is our Siva sir. Today we are going to discuss about human eye and colorful word. Human eye and colorful word. So welcome to the class. Welcome to the class. So this is our Siva sir. Hello, hi everyone. Welcome to the Student the Brand channel. So myself, Siva sir. Today we are going to discuss about human eye and colorful word. Very important chapter. Okay, very important chapter. Myopia, 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 myopia. Near distance we can see, far distance we can see. Myopia, 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 myopia. Myopia, 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 myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. Myopia, 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 myopia. Near distance we can see, far distance we can't see. Myopia, 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 myopia. For correction we are using concave lens, concave lens, concave lens, concave lens. Hey, come on! Myopia, 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 myopia. Near distance we can see, far distance we can see. Myopia, myopia, myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. So now we are going to discuss about gone my hypermetropia. Hypermetropia. Everybody. Come on, welcome to the class. Hypermetropia. 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 Far distance we can see. Near distance we can see. Hypermetropia, 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 hypermetropia. For the correction, we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, 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 hypermetropia. For the correction, we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, 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 hypermetropia. For that correction, we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, 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 hypermetropia. Convex lens, convex lens, convex lens, convex lens. Hypermetropia, hypermetropia, convex lens, convex lens, convex lens. Myopia, myopia, myopia. Concave lens, concave lens, concave lens, concave lens. Hypermetropia, convex lens, myopia, concave lens. Hypermetropia, convex lens, myopia, concave lens. Okay, welcome to the class, everybody. Welcome to the class. So this is your Shiva sir. This is your Shiva sir. This is your Shiva sir. Welcome to the Student the Brand. Myself, I am Shiva sir from Student the Brand. Student the Brand. So this is my channel. Today we are going to discuss about a very important topic that is about that is about what is that? That is human eye and colorful bird. Human eye and colorful bird. So we can see all the things, right? If you close your eyes, you can't able to see anything. You can't able to see anything. You can't able to see anything. Once you open your eyes, you can see the beautiful world around us. You can see the beautiful world around us. You can see the beautiful world around us. Yes or no? Yes or no? Yes or no? So today we are going to discuss about human eye and colorful world. Human eye and colorful world. So welcome to the world of physics. In that, Shiva sir is the teacher, right? So come to the point. So now I am going to discuss human eye and colorful world. Human eye and colorful world. Human eye and colorful world. Colorful world. Okay. So in this topic, so this is about CBSE Grade-10 physics. CBSE Grade-10 physics. CBSE Grade-10 physics. CBSE Grade-10 physics. So now I will draw the human eye part. Human eye. So especially here we are discussing about human eye. So completely we have to discuss about human eye. Okay. So human eye we have to discuss. Human eye, we have to discuss. So how to draw the diagram, everything, how to draw the diagram and their parts and function. Their parts and function will draw their parts and function. Okay. So how to draw the human eye? Normally, so in the exam, definitely that question will come in exam time. So that question definitely they will give. So that is very very important. That is very very important. Parts, definitely parts they will ask. Parts they will ask for at least. 3 marks question, at least 1 mark, either either so parts, cornea, iris, people, ciliary muscles, so like a retina, and in that retina, so rods and cones are there. So about that also we'll discuss now. So now we can see. So I'm considering, I'll draw the diagram. Okay, I'll draw the diagram. So work out on it. Okay. How to draw the diagram? So I'll show you how to draw the diagram. So how to draw the diagram? How to draw the diagram? How to draw the diagram? Now I'll show you how to draw the diagram. First one. So draw the circle, human eye. First we are discussing about completely human eye. Okay. So human eye. Human eye I'm discussing. Human eye. Human eye. Okay. So draw the circle. Draw the complete circle. So you must draw the complete circle. You must draw the complete circle first. So you must draw the complete circle. Okay. So after drawing you can connect. After drawing you can connect. Okay. So here, so first to draw the. So you're drawing. So now I'm considering this. So you can see first second part is you can rub you can rub the portion. So front and back we can rub. Okay. So here you can see. So here you can rub here this portion and this portion. If you rub it, this portion and this portion, if you rub it, then we'll get it. Okay. How you are drawing, you can see. So you can connect this one. You can connect like this. Okay. So if you can connect like in this way. So in this way you can connect. And here, so you can draw the optic now. Optic now. So here the front portion is called the front portion, whatever it is there, that is cornea, front bulged surface. So bulged out. Okay. So that is cornea. That is cornea I'm taking. That is cornea. This is the cornea. Okay. And so this one is the eye. Hi Daniel, welcome to the class. And Vladimir, thank you. And take tension. So this is the teaching aid. And Olive Liz. So hi. So now we are considering. So if you are taking here, this is the lens. Lens I am taking. Lens I am considering like this. Lens. Okay. So here I am considering. Here I am considering. Okay, so these are the optic nerves, optic nerves, optic nerves, optic nerves. I'm discussing the optic nerves. Okay, like this, optic nerves. And here, so these are the ciliary muscles, ciliary muscles. These are the ciliary muscles. Okay, here also ciliary muscles are there. Ciliary muscles until here. Until here. Okay. So, and this entire portion is filled with this entire portion. Hi, someone phone you like that. Hi, welcome to the class. Okay, so here I'm considering this portion, whatever the portion is there. Okay, this portion, this front portion is called cornea, 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 and this portion is called ciliary muscles, ciliary muscles, ciliary muscles. Okay, and here also ciliary muscles only. So in the textbook they given like this, they extended. So we can take like this also. Ciliary muscles, and this portion is iris, iris, and this bottom portion is iris. Okay, and here so jelly type liquid is present, that is aqueous humor, aqueous humor, aqueous humor. So this entire portion is called vitreous humor, vitreous humor, vitreous humor. Okay, so this one is eye lens. Eye lens or crystalline lens. Eye lens or crystalline lens. So here is the retina will be there in this portion. Retina will be there. Retina, retina. So this is the optic nerve. Optic nerve. So optic nerve. This entire is human eye. Human eye part. Human eye. Human eye and parts. Human eye. So this is the human eye. So you can see. So now you can observe. Now you can observe one by one. We will discuss. One by one we will discuss. One by one. One by one we will discuss. First one you are talking about cornea. Cornea is the front portion. So cornea is the front layer, protector layer. Most of the refraction takes place at this cornea. So here you can see. So this is a cornea, front layer, protector layer of the human eye. So most of the refraction takes place at this point. Most of the refraction takes place at this point. And next one we are going to the ciliary muscles. Ciliary muscles means when you are seeing the nearby object and far by object. So if I want to see the nearby object and far by object, nearby object and far by object. Okay, so what happens? It adjusts the eye lens. It adjusts the curvature of the eye lens. So when you are seeing nearby object, if you are seeing nearby object, eye lens become thick. Eye lens become thick. So we are seeing here. So if you want to see the nearby object, so this is the nearby object. Okay, I'm standing here. If I want to see the nearby object, this is nearby object. So eye lens become thick. Focal length decreases. Eye lens become thick. Focal length decreases. By that we can able to see the nearby object. So when you are seeing the far distance object, if you are seeing far distance object, eye lens become thin. So eye lens will be relaxed. Ciliary muscles will be relaxed. Eye lens will be thin. Focal length increases. So by that we can able to see the far distance object. By that we can able to see the far distance object. Far distance object. And coming to the iris. So iris is the dark muscular diaphragm. So this is the iris. This portion and this portion is iris. This portion and this portion. So this gap is called pupil. Pupil. So Pupil. So spelling is Pupil. So you can pronounce pupil like that. Okay. So iris is a dark muscular diaphragm. It controls the size of the pupil. So this is the iris. Iris is the dark muscular diaphragm which controls the size of the pupil. Pupil will control the amount of light entering into the eye. People will control the amount of light entering into the eye. So this is a gap, this gap. So when a light enters through this, Okay, when light enters to that, so it controls the size of the amount of light entering into the eye. How much light it is required to enter, so it will enter. So it will control the size. This people, so people will control the amount of light entering into the eye. Eye lens is a crystalline lens. 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 Whenever light falls on it, whenever light falls in, eye lens is a crystalline lens. Whenever light falls on it, whenever light falls on it, whenever light falls it converts the light rays. It converts the light rays and make it falls at retina. Make it falls at retina. So that is a eye lens. So that is a eye lens. Eye lens is a crystalline lens. Next one, vitreous. So here jelly type liquid is present. So that is aqueous humor. So this portion, this complete portion is filled with jelly type liquid from cornea to eye lens, from cornea to eye lens, from cornea to eye lens. That is aqueous humor. Aqueous humor. Aqueous humor is a jelly type liquid is present between cornea and eye lens. Cornea and eye lens. So jelly type liquid present between cornea and eye lens. So it provides the it gives the sufficient it gives the blood and nutrition to the central cornea. It gives the blood and nutrition to the central cornea because it won't have, so it doesn't have its own blood system. And coming to the next one, so this entire portion is filled with vitreous humor. This entire portion is filled with vitreous humor from eye lens to retina. From eye lens to retina. From eye lens to retina, this entire portion is filled with vitreous humor. This entire portion is filled with vitreous humor. That is, it is a jelly type liquid is present between it gives the sufficient force and temperature, sufficient force and pressure. Vitreous humor is a jelly type liquid present between eye lens and retina. It gives the sufficient force and pressure to maintain that shape. And coming to the retina. Retina is the light sensitive screen. Retina is a light sensitive screen. So where light rays will meet at retina. So it is a light sensitive screen. Okay, so light sensitive screen. So at the retina, so there are two light sensitive cells are there, rods and cones. There are two light sensitive cells are there, rods, and first one is rods and second one is cones. So rods help the intensity of the light. Cones sense the color of the light. Rods sense the intensity of the light. Even in the night time also we can able to see during night time. So because if we have more rods, even in night time also we can able to see. If more cones are there, so we can able to see the daytime, and at the same time it identify the colors. So it sense the colors. Rod sense the intensity of the light. Cone sense the color of the light. And optic nerve. Coming to the optic nerve. So whatever the image is forming at retina, that will convert in the form of electrical signals. Whatever the image is forming at retina, that will convert into electrical signal that will pass to the brain through optic nerve. Generally, whatever we are seeing, the image, those are the 2D object. So brain will give the additional information. Brain will add the additional information. That is, so normally if you are taking the water bottle, so if you are considering the water bottle here, so here you can see how much depth it is filled, how much depth is the water is filled. So the water is filled. How much height is it is filled. So how much depth is from us, how much distance it is. So everything brain will give the additional information. How much depth it is, so how much depth the water is filled, how much height it is filled, and how much width it is. Everything, the 3D information. Brain will give the additional information, that is 3D information. Whatever we are seeing, that is a 2D image. 2D image. Why we are seeing only 2D image? So after so what are the image is forming at retina? So that is real and inverted. Real and inverted image is forming at retina. So that will convert into electrical signal that will pass to the brain through optic nerve. So after reaching to the brain will give the additional information. Brain will give the additional information. Okay. So brain will add the additional information, that is how much depth it is, how much width it is, how much height it is, and how much distant it is from us. So everything it will give that. That is 3D information. That is about image and converting electrical signal reach to the brain. And a blind spot is there. So one more point is there here, blind spot is there. So there won't be any image will form. Blind spot, there won't be any image will form. So light will not reach to that point. So there is a dark place, that is that is the reason it is called blind spot. Okay. So at retina, so more cones and rods are present. If more cones and rods are present, so at retina, that is called yellow spot. If more rods and cones are present at retina, that is called yellow spot. If more rods and cones are present at if more rods and cones are present at retina, so that type of image is called so there more rods and cones are present at retina. Okay, so at one point more rods and cones will be present, right? So that point is called yellow spot. If more rods and cones are present at retina, so that is called yellow spot. I hope this is about complete detail about human eye and parts and their function. Now we can see once again cornea. Cornea is the front layer, protective layer. Most of the refraction takes place at cornea. Next one, ciliary muscles. These are the muscles which will adjust the curvature of the eye lens when we are seeing the nearby object and far object. So it gives the power of accommodation, ability of the eye lens to adjust its focal length. So by seeing so when we want to see the nearby object and far object, by using of ciliary muscles, eye lens will adjust the curvature. Eye lens will adjust the focal length. Eye lens will adjust the focal length. So by that we can able to see nearby object as well as far object. Okay. Next one, coming to the iris. Iris is a dark muscular diaphragm. Which controls the size of the pupil. Iris is a dark muscular diaphragm which controls the size of the pupil. So people will control the amount of light entering into the eye. People will control the amount of light entering into the eye. People will control the amount of light entering into the eye. So eye lens is the crystalline lens. Whenever the light falls on it, eye lens is a crystalline lens or convex lens. So hi phony. Eye lens is a crystalline lens. How much our light rays falls on it, it will converge and make it falls at retina. So retina. So here one more is there. So that is aqueous humor. Aqueous humor is there in between this one. That is aqueous humor between cornea and lens. Between this portion, between cornea and eye lens, this portion is there. This portion is completely filled with jelly type liquid material, that is aqueous humor. Aqueous humor gives the sufficient provides the blood and nutrition to the central cornea. And the next one, this entire portion is filled with vitreous humor. Vitreous humor is the jelly type liquid present between eye lens and retina. And retina. So it provides sufficient force and pressure to maintain that shape. Coming to the retina, Retina is a light sensitive screen. Retina is a light sensitive screen. So whenever light meets, whenever the light rays meet at retina, so image will form. What type of image will form? What type of image will form? Real and inverted. Real and inverted image will form at retina. So there in retina, there are two light sensitive cells are there, rods and cones. Two light sensitive cells are there, rods and cones. So rod sensitive intensity of light, rod sensitive intensity of light. If more rods on there, we can. If more rods are there, we can able to see during night time also. Cones coming to the cones. If more cones are there, we can able to see daytime also. You can identify the colors. We can identify the colors of. We can identify the colors. We can identify the colors. Okay. So coming to the optic now. So whatever the image is forming at retina, whatever the image is forming at retina, that will convert in the form of electrical signal. That will convert in the form of electrical signal. That will reach to the brain. Reach to the brain through optic nerve. Through the optic nerve. These are the nerves will carry the information. These are the nerves will carry the information. You can see in movies. So the information is passing through the nerves. So like so electrical signal, electrical impulse. So through this optic nerve only it reach to the brain. So blind spot. So there won't be any image will form. Light rays will not reach to that point. So there a dark place is there. That is called blind spot. So here if more rods and cones are present at the point in the retina. If more rods and cones are present at retina. If more rods and cones are present at retina. So if more rods and cones are present at retina, that is called yellow spot. Yellow spot. More rods and cones are present at retina. That is called yellow spot. That is called yellow spot. Okay. So whatever we are seeing, that is only 2D image. Whatever we are seeing, that is only 2D image. So brain will give the additional information, how much depth it is, how much width it is, how much distance it is, everything it will give. So brain will add the additional information, how much depth it is and how much width it is. I hope it is very clear. So this is about a brief discussion about human eye. Brief discussion about human eye. So now we are going to the next one. Now we are going to the next one. Next one is power of accommodation. Power of accommodation is the ability of the eyelens to adjust its focal length. So power of accommodation, ability of the eyelens to adjust its focal length. So that is called power of accommodation. Power of accommodation. So which part is responsible for the power of accommodation? Which part is responsible for the power of accommodation? So ciliary muscles are responsible for the power of accommodation. Power of accommodation. So now we are going to discuss about near point and far point. So near point and far point, we'll see now. Near point and far point. Okay. So we can see. I'm taking now here CBSE Grade-10 physics. So power of accommodation. So we'll discuss power of accommodation. So second thing, near point. So third point, far point. So power of accommodation is nothing but ability of the eyelens to adjust its focal length to allow the light inside of it. That is called power of accommodation. Power of accommodation. Next one. So near point and far point. Near point and far point. So near point and far point we'll discuss. Near point is nothing but the minimum distance up to which. So near point. So the minimum distance up to which. This is also called least distance of distance vision. The minimum distance up to which a person can able to see the minimum distance up to which the person can able to see the object without any strain. The minimum distance up to which the person can able to see the object without any strain, that is called. Okay, sorry for the interruption. The minimum distance up to which. The minimum distance up to which the person can able to see the object without any strain, without any pain, without any struggle. So that is called a near point. So that is also called the least distance of distance vision. So normally if you are taking least distance of distance. So if you are taking the pen, if you are taking any pen. So if you are placing certain distance, we can able to see comfortably. So if you take very near. So very near, if you take very near, what happens? So we can able to see, but after certain time, our eyes will get strained, our eyes will get pain, because so at certain distance only, so ciliary muscles can contract and see the object. Beyond, below that limit, so ciliary muscles can't contract, ciliary muscles can't contract. Okay, so the minimum distance up to which the person can able to see the object, that is 25 centimeter. For a healthy person, for a normal person, so the minimum distance is 25 centimeter. Least near point is 25 centimeter. That is also called near point, and that is also known as least distance of distance vision. Coming to the far point, the maximum distance up to which a person can able to see clearly without any strain. The maximum distance up to which a person can able to see clearly without any strain, that is called maximum point. So maximum point is infinity for normal healthy person. Maximum distance is infinity for a healthy person. So infinity. So this is about near point and far point. This is about near point and far point. So next one, we are going to the defects. Normally some people can't able to see the near distance, and some people can't able to see the far distance object. Some people can't able to see the near distance, some people can't able to see the far distance object, or sometimes people can't able to see near as well as far distance object. So what is the problem? What is the concern? So here the concern is so the person having refractive defects. What are the refractive defects? Refractive defects are nothing but, so normally I said, so convex lens I said, right? So I'll show you the convex lens. So this is the convex lens. Okay, so this is the convex lens. You can see this is the convex lens. Okay, so I made it. This is the convex lens. You can observe the convex lens. So whenever the light falls on it, so convex lens does not refract the light properly. So whenever the light falls on it, if the convex lens does not refract the light properly, then so defects will arise. So because of that reason, the person can't able to see the objects clearly. So based on that one, based on the refraction, based on the refraction. So if the refraction is not done properly, based on that one, defects are divided into two types. So defects are so like many we are discussing according to our syllabus. So there are three defects are there. One is myopia and hypermetropia. So myopia. So what is myopia and hypermetropia? We will discuss. And presbyopia also there. Myopia, hypermetropia, presbyopia, cataract, and astigmatism. So these defects will discuss. These defects will discuss. Now we are going to discuss about myopia. So myopia, considering myopia. So the defect is myopia, right? Come on, welcome to the student brand. So this is very important. Myopia topic we are going to discuss. Myopia topic. So myopia is nothing but, so I'll sing with the song. The concept I made in the form of song. I converted in the form of song. Just listen here. Myopia, 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 myopia. Near distance we can see, far distance we can see. Myopia, 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 myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. Myopia, 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 myopia. For that correction, we are using concave lens, concave lens, concave lens, concave lens. So I made the concept in the format of song. So whatever I sang the song, so I'll explain that song. You listen here. I'm taking the object. So I'm standing here. The person is standing here. The person is standing here. So he can see the near distance. So 25 centimeter. The least distance is 25 centimeter, and the far point is infinity. So far point is infinity. You can see infinity point. So this is the infinity point. So 25 centimeters. So myopia, myopia, myopia. Near distance we can see near distance. So nearby object he can see, but he can't see the far distance object. Nearby object he can see. As I said, nearby object he can see. So but we can't see the far distance object. But between this portion he can see. Between that portion he can see. That is nothing but far point of myopic person. Far point of myopic person. So 25 centimeter you can see. That is a near point. So infinity you can't see, but somewhere else between infinity and 25 you can see. That is a far point. So for myopic person, thank you, Tarunya. For myopic person, for myopic person, for myopic person, the near point, the far point is less than infinity. For myopic person, far point is less than infinity. For myopic person, so for myopic person, far point is less than infinity. I'll draw the diagram so you can observe. So, yeah, as I said, the person can't able to see infinity. As I said, person can't able to see infinity. But this point he can able to see, right? Jeevanesh Krishna Vyas. Thank you. So here you can see I am taking the far point of myopic person is so less than infinity. Less than infinity you can see here. I am taking this from this point like this. From here the letters are incidenting. So this is the far point of myopic eye. Far point of myopic eye. Next one. This is the first one. Coming to the second one. So as I said, from infinity, whatever the light rays are coming from infinity, so the person can't able to see. If the light rays are coming from infinity, the person can't able to see. So light rays are coming from infinity, will see. So this is near point. Anyway, again. So I am taking the light rays. So these dotted lines representing light rays are coming from infinity. These dotted lines are representing light rays are coming from infinity. So those light rays will meet. Those light rays will meet here. Those light rays are meeting in front of the retina. Actually, this is the retina. So if the light rays meet at this point only, if the light rays meet at this point only, the image will form. So if the light rays are meeting at retina only, we can able to see the image. We can able to see the image. If the light rays falls at retina, if the light rays meet at retina only, if the light rays are meeting at retina only, the image will form. If the light rays are meeting at retina only, the image will form. If the light rays are not meeting at retina, we can't able to see. We can't able to see. So that's why this point, far point, if the light rays are coming from infinity, so these dotted lines represent light rays are coming from infinity. So how to correct? So first diagram is this one, second one, and coming to the third one is correction. So this is the myopic eye. Myopic eye. Myopic eye. Okay. Third one you can see, third diagram. So here you can see, now, now, so I'm drawing lines. So which lens we are using? Concave lens. Concave lens. So I'm taking two light rays. Those are so after that it will meet. Okay, so this is a concave lens. Actually here, so from here, what are the points? This is the near point. Near point, this far point. So that is infinity. What are the light rays are you are taking? So from here it should reach. From this lens, the light ray should meet at far point. So that's enough. Okay. So this is a correction of myopia. Correction of myopia. Okay. Any doubts? So this is a correction of myopia. Okay, so these are the diagrams we have to draw like this. Okay, I hope it is very clear to you all. Understood? So this is the PowerPoint. See, simple. You must. So you must see. Okay, so you must do one thing. You have to understand the logic. You have to understand the logic. As I said, this logic. If you remember, this diagram drawing is very easy. So you can draw in easy way. So you can draw in easy way. Okay, you'll get an accurate manner. You'll get an accurate manner. So you have to show the diverging nature, because the concave lens is a diverging nature. Concave lens is a diverging nature. So try to work out on concave lens. Okay, you must show the concave lens is a diverging nature. Diverging nature. Understood. I hope it is very clear to you all. Now you can see a far point. See, from this point, if the light rays, so first point is myopia. Myopia is nothing but, so he can see the near distance, but he can't see the far distance object. Myopia is nothing but he can see the near distance object, but he can't see the far distance object. So if the light rays are coming from infinity, he can't see, but somewhere between 25 to infinity he can see. So the far point of myopic person is less than infinity. The far point of myopic person is less than infinity. The far point of myopic person is less than infinity. Far point of myopic person is less than infinity. So from this point he can see. So that is the first point. Far point of myopic eye. So if the light rays are coming from this point, so image will form at retina. So we can able to see the object. So if the light rays, suppose if the light rays are coming from infinity, what happens? So you can see here, if the light rays are coming from infinity, those light rays will meet in front of the retina. Those light rays will meet in front of the retina. Those light rays will meet in front of the retina. So next one we are going to the correction of myopia. So what lens we are using? Concave lens. What lens we are using? Concave lens. What lens we are using? Concave lens. To correct the defect of myopia, we are using concave lens. So we are using concave lens. I hope it is very clear to you all. So do you have any doubts? You can ask. Otherwise, I'll go to the next topic. So once again, simple logic, easy logic. If you remember this logic, you can draw the diagrams in easy way. First one, so 25 infinity you can't see. So a far point somewhere between less than infinity can see. So 25 anyway already we can see. So no problem. So leave that one. We need to work out on only these two. Far point is infinity, less than infinity. So this point. So first diagram is completely related to far point. Second diagram is, so infinity, if the lights are coming from infinity, image will form here. So we can't able to see. Third diagram is correction. That's enough. And coming to the next one. So hypermetropia, I'll explain. Just check once. Hypermetropia. So hypermetropia you can see. So I'll sing one song related to hypermetropia. I already sang. So I already sang one song, but just before going to the concept, just once again a reminder. Hypermetropia. 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 hypermetropia, hypermetropia, hypermetropia. For a distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction, we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, hypermetropia, convex lens, convex lens. Hypermetropia, hypermetropia, convex lens, convex lens, convex lens. So here you can see, so this is a convex lens. So this is the convex lens I did. Okay, so very so with this lot of hard work, I did this one. Okay, this is a convex lens, convex lens, right? Yes. So we'll draw the diagram. Now I am drawing the diagram. So hypermetropia. So I'll explain the incident. I'll explain the same incident. I'm explaining the same incident. So you can see here. I'm taking here. So the person can't able to see 25, but he can see the infinity. Infinity point he can see. So the person can able to see infinity point. Okay. So you can see infinity, but he can't see 25. But so between infinity and 25, you can see somewhere here. That is a near point of hypermetropic person. Near point of hypermetropic person. Near point of hypermetropic person. Now we will draw in the diagram manner the same situation. So he can't see the 25, but he can see near point, far point he can see, but 25 to infinity he can see between one point. Somewhere else he can see. That is a near point of hypermetropic eye. So now we will draw the diagram. So I already said this point you can see. So this is the n dash. This is n. From this, this is the near point of hypermetropic eye. Near point of hypermetropic eye. Hypermetropic eye. Okay. So next one. As I said, he can't see 25 centimeter. If the light rays are coming from 25 centimeter, where image will form? Light rays will form beyond retina. Here light rays will form. Okay. So this is near my hypermetropic eye. This is a hypermetropic eye. Hypermetropic eye. So now correction will see correction of hypermetropia. Correction of hypermetropia. So for correction of hypermetropia, which lens we are using? Convex lens. We are using convex lens. So draw the convex lens diagram. So I am using convex lens. So here I am using convex lens. Okay. So now so one light ray I am taking. So here, so if the light rays are coming from the light rays are coming from N. If the light rays are coming from N, what happens? So one light ray I am taking like this. Another light ray. So again it will converge. Again it will converge. So light rays will be converged and meet at retina. Okay, so light rays will meet at retina here at this point. So if we are extending these light rays, so we have to extend from the lens. We have to extend. Abhinav? Yeah, of course. See, so here the point is, Abhinav, so you asked one question. How can we remember? So for you only, see, in our eye, convex lens is there. I explained human eye, so you can see here. In this also, whatever I wore the dress, in this also here, convex lens is there. Convex lens. Convex lens is there. Yes or no? Here also convex lens. Here also convex lens. This also convex lens. This also convex lens. So by default, convex lens will be there in our eye. Okay. So for hypermetropia, see, I will tell a simple logic to remember these three. Myopia. Second one is hypermetropia. So simple logic to remember, just for remembering sake, I am saying this is short word compared to hypermetropia. Yes or no? This is very short word. So this is short. That's why we are seeing near distance. Yes or no? We in myopia, what is the definition of myopia? I already sung a song, right? So one more logic also I given. Myopia. Near distance we can see far distance we can see myopia, 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 myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. If two different lens, so for correction we are using concave lens. Already it is there inside convex lens. If two different lenses are used, that is myopia. Short word we can see near distance. Short word near distance. Short word near distance. Short word near distance. Hypermetropia. It is long word. That's why we can see long distance. It doesn't mean, sir, only because of the short word we can see near distance. It's not like that. For remembering sake, I am saying that one. Okay. For remembering sake, I am telling it is a short word. So for strong remember. Okay, na strong for like a blind marks, like a blind marks. We can remember in a blind way. That is short word near distance. It is correct only. There is no mistake in that. It is correct only. Myopia. So we can see near distance. There is no wrong in that. Short word, near distance. Hypermetropia, long length compared to these two we are comparing. We are comparing with these two. Hypermetropia, we can see long distance object. Hypermetropia, 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 hypermetropia. Far distance, we can see. Far distance, we can see. Near distance, we can see. Far distance, we can see. Near distance, we can see. Hypermetropia, 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 hypermetropia. For that correction, we are using convex lens, 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 hypermetropia, convex lens, hypermetropia, convex lens. Now you tell, is it easy? Will you forget? Will you get confused? Never, never. Okay. So I am, see, why I am doing all these things means because this entire question will get, so they will give for 5 marks in the exam. In this entire question. So they'll ask to draw 3 diagrams or sometime 1 diagram also, sometime one diagram also, one diagram also, like that, one diagram also, like that. So very simple way, very easy way we can remember. We can, at least if you sing my song, if you learn my song, myopia and hypermetropia, definitely you can remember. So you can sing at any time. So when you are playing, when you are, it depends. So you can remember my songs. If you sing my song, that's enough. You can remember. You'll never forget. That too, lyrics are good. This is a correction of hypermetropic eye. Hypermetropic eye. Okay, so this is a correction. I already said this logic. For my hypermetropia. For myopia also I said the logic. Okay, na? For drawing the diagram. See, I given nearly five techniques. to do this, to excel in this concept. 5 techniques. Technique number 1, song I created. We can remember. Technique number 2, words, myopia, hypermetropia. Yeah, I'm taking online classes. So if you need further discussions, you can contact this number 984981280. 984981280. This is my number. You can contact me through this number. Anyone required classes, not only physics, remaining all subjects. So I'm working in my own brand, Student the Brand. So not only physics, remaining subjects also maths. So biology, social, English. So all subjects also you can get. Okay. So you can contact me through that number. So that is you can see that is number I given here 984981280. Okay. So that's enough. Come to the point. Here I given 5 techniques to remember the myopia, hypermetropia, because these questions will come for 5 marks, damn sure. In the human and colorful world, only these questions are highly important. Okay, any test you see, midterm, unit test, pre-final, even annual exams, board exams also, these questions are very, very important. That is the reason I given extraordinary techniques, marvelous techniques. Once you follow this one, you never confuse with the concept. First one, song I created, so you can see at any time. Myopia, myopia, myopia. Myopia, myopia, myopia. Near distance we can see her. Far distance we can see her. Myopia, myopia, myopia. For that correction we are using. Bro, what bro? For that correction we are using concave lens, concave lens, concave lens, concave lens, concave lens, concave lens. Myopia, myopia, myopia. Myopia, myopia, myopia. Concave lens, concave lens, concave lens, concave lens. So you see, by watching this, you can observe this. So you won't forget it. Okay. So hypermetropia. So myopia, concave lens. Hypermetropia, convex lens. As it is. See the diagrams also here. So convex lens at the end we used. Convex lens. This is a concave lens. Concave lens for myopia. And a convex lens for hypermetropia. So hypermetropia song also we can sing. Hypermetropia, 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 hypermetropia. Far a distance, we can see. Near distance, we can see. Near distance, we can see. Hypermetropia, hypermetropia. For that correction, we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, convex lens, hypermetropia, convex lens. That's enough now. So in easy way, see, Easy way. So I said this many techniques. Why I'm using this many techniques? So uh, concept cannot escape from us. Okay, should not escape from us. So like that. That is the reason. See, normally, so only one thing cannot stolen from us. That is our knowledge. Only our knowledge. No one will steal from you. So try to learn the concept in a strong way, in a better way, extraordinary way. Once you remember, you should not forget it. That like that. You have to gather the techniques to remember. Okay, to recall. Whenever we want immediately, we have to recall that concept. So like that, I am creating. First one is song I created. Second one is so myopia, hypermetropia. So according to the words we can tell. Third one, so this one we can see this one. Third one, this concept. Fourth one, diagram, how to follow the diagram. That's enough. No, fifth one, once you recalling the techniques, whenever we want we can sing. Yes or no? Song can be remembered, can be reproduced in any way, at any time. So, not I see. I'll tell a small point. Sir. Sir, we can sing like that only. So maybe see throw it here at any time. If you remember also, you'll get the concept. See, it's not about even one line. One line also, it is not other than the subject. So it is one, even one line also, it is not a sub, it is not a, it is not out of syllabus. It is about completely related to the content. Myopia, 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 myopia. Near distance we can see ya, far distance we can't see ya. Myopia, 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 myopia. For that correction bro, what bro? For that correction we are using concave lens, concave lens. Two different lens. A last technique also. Two different lens it is used. Myopia. Concave lens outside, convex lens inside. Hypermetropia. So same lens. Same lens. Yes or no? See how many techniques? How many techniques? So in easy way, you can recall, you can recognize, we can remember. Is it right? So that's why that's why that's why that's why I created all these methods. I created all these methods. That's why I created all these methods for remembering, for recalling, for recognizing, for identifying, right? So I hope it is very clear. So next we are going to the next topic. So myopia, hypermetropia completed. Myopia and hypermetropia completed. So then we are going to the next topic. Next topic. Next topic. Next topic. We will go to the next one. Refraction through prism. So refraction through prism. Now we'll discuss about refraction through prism. I will explain about refraction, how it will be, how we are taking. So now you are considering here. So I'm taking the prism. I'm taking the prism. I'm taking the prism here. I'm taking the prism here. So this is a prism. Prism. So incident ray. I'm taking the incident ray here. This is the incident ray. Okay. So if below this one we have to take. So here, whenever the light ray incident on it, whenever the light ray incident on the prism, whenever the light ray incident on the prism, it's split into 7 colors. 1, 2, 3, 4, 5, 6, 7. Okay, so those 7 colors will form like a band on the screen. 1, 2, 3, 4, 5, 6, 7. Those 7 colors will form like a band on the screen. Okay, so the splitting of white light into 7 colors. You can see violet, indigo, blue, green, yellow, orange, red. Violet, indigo, blue, green, yellow, orange, red. So splitting of white light into 7 colors is known as dispersion. Dispersion. Second one is spectrum. Spectrum. Splitting of white light into 7 colors is known as dispersion. The splitting of white light into 7 colors. The splitting of white light into 7 colors is known as dispersion. So splitting of white light into its constant colors. Splitting of white light into its constant colors is known as dispersion. Dispersion. Okay. So next one, those 7 colors will form like a band on the screen. Those 7 colors will form like a band on the screen, that is called spectrum. Those 7 colors will form like a band on the screen, that is called spectrum. So splitting of white light into 7 colors is known as dispersion. Those 7 colors will form like a band on the screen is called what is that? Spectrum. So here Newton want to split the color, so he sent over the prism, so it's split into 7 colors. Again still he want to split the colors, so he placed the normal prism, so besides of it, so we didn't get. So it depends on how it will split, how it will deviate. Violet deviate the most, whereas red deviate the less. It depends on the refractive index, it depends on the wavelength, and depends on the deviation. So deviation depends on the deviation. Okay, so based on that one, so the light rays deviate, the light ray will bend towards the normal line. Okay, according to the. So now you are considering. So recombination of spectrum of white light. 3 marks question. Recombination of spectrum of white light. So normally, so Newton did. So actually, he placed the prism. He sent over it. So 7 colors. So 7 colors form. Again, he placed the same prism in this format, but he didn't get. So those 7 colors again formed on the screen. So he didn't get that one. So instead of that, he placed the inverted prism. So Newton, so he placed the inverted prism like this. So like this he placed. So like this. Okay. So this is the incident light ray. So it's split into 7 colors. So here I am drawing the 7 colors. So red and violet only I am drawing like this. So exactly it won't, somewhat distance below this. So I am considering here. So this is the white light. White light. Okay. So this is the prism 1. This is prism 2. So this we are getting white light. So red and violet. Okay, so when the white light pass through it, it's split into 7 colors. So those 7 colors will okay. So here split into 7 colors. Again, those 7 colors will fall on the second prism. So those 7 colors will combine and get white light as a outcome. White light as a outcome. So you can able to see this is a recombination of spectrum of white light. Recombination of spectrum white light. Recombination of spectrum of white light. Spectrum of white light. Recombination of spectrum of white light, very very important for 3 marks. So they will give for 3 marks in the exam. Just check it once. Next one. So rainbow formation by water droplet. So normally if you are taking each and every water droplet act as a rainbow. Each and every water droplet act as a rainbow. Each and every water droplet act as a rainbow. So I am considering here. So I am taking the okay, each and every water droplet act as a prism. Each and every water droplet act as a prism. When light falls on it, each and every water droplet, act as a prism. Whenever light falls on it, it's split into 7 colors. So I'm considering here. So like this. So after that, it's split into okay. Violet, red. So what is the phenomena involved in the formation of rainbow? You can take the light rays. So we can take here and we can take like this also fine. That is your wish. So what is the phenomena involved in the formation of rainbow? The phenomena involved in the formation of rainbow is refraction. Second one is dispersion and internal reflection. Sir, why can't we go for total internal reflection? Because some of the light will be absorbed, some of the light will be refracted, and some of the light will be reflected. So we can't take entire light. So we can take only internal reflection. See, whenever the light falls on the prism, water droplet. Actually, it is water droplet. Rainbow formation by water droplet. Rainbow formation by water droplet. Rainbow formation by water droplet. Water drop, you can say. Simply we can say water drop. Okay. So like that. So whenever the light falls on it, it's split into 7 colors. Those 7 colors. See, refraction first. Whenever the light incident on it, refraction takes place. Then dispersion. So refraction, dispersion. Then internally reflection takes place. Refraction, dispersion, internal reflection. What is the phenomena involved in the formation of rainbow? Refraction, dispersion, internal reflection. What is the phenomena involved in the formation of rainbow? Refraction, dispersion, internal reflection. Whenever the light falls on it, it's split into 7 colors. Those 7 colors will form. Again, those will reflect back. So refraction, dispersion, internal reflection. So this phenomenon is This is the phenomena involved in the formation of rainbow. This is the phenomena involved in the formation of rainbow. This is the phenomena involved in the formation of rainbow by water drop. This is the phenomena involved in the formation of rainbow by water droplet. I hope it is very clear. So once again, the phenomena involved in the formation of rainbow: refraction, dispersion, internal reflection. Refraction, dispersion, and internal reflection. Refraction, dispersion, and internal reflection. So one more we'll go for one more concept I'll explain. So that is about scattering of light. Scattering of light. So I'll discuss about scattering of light. So before scattering of light, we'll go for atmospheric refraction. Atmospheric refraction. Atmospheric refraction. Atmospheric refraction. First one. Second one will go for scattering of light. Scattering of light. So one example I will tell for atmospheric refraction. So here your friend is standing here. So you are standing here. So your fire is there. Your fire is there. So like this, fire is there. Okay. So like this, and so one more friend is standing here. Okay. So you're standing. So person here I'm taking person B. So person B is seeing the person B through the fire. So through the hot air like this. So here in the other side, that is cold air. Here is hot air. Okay. Hot air, cold air. When we weaving through that, when we weaving through the fire, so the person B appears flickering. The person B appears flickering or wavering, wavering. So when we weaving through the fire, so it appears flickering, so fluctuating. So what is the reason? When light ray passing through denser, rarer. See, actually, hot air act as a rarer medium. Cold air act as a denser medium. So hot air act as a rarer medium. Cold air act as a rarer medium. Cold air act as a denser medium. So when the light is passing from one medium to another medium, when light ray is passing from one medium to another medium, so the refraction takes place. Because of that reason, the person B appears to be flickering. Fluctuating. Yes or no? Flickering, fluctuating. So that is normal. That is normal method. That is normal method. But here you can see. So from far distance onwards, like nearly stars. So there are many kilometers. From many kilometers onwards. So light ray is coming from us. Okay, light ray is coming from that point. Okay. So here I'm standing here. So I'm standing here. The person is standing here. So star is here. Okay, star is here. Okay, best example you can say star is here. Okay, so like this star I'm taking. This is star. From here the light ray is coming. Because so atmosphere, so the particles present in the atmosphere is not constant. So each and every time it changes. Or not. So when the light ray is moving from far to so light ray is coming from star to us. Okay, from here to here. So there are so many refraction. Refraction takes place by the atmosphere. There are many refractions. Continuously refraction takes place. Continuously refraction takes place. So there are many refraction takes place. Continuously refraction takes place from this to here, from here to here. So from star to us, there are many refraction takes place. refraction takes place. Because of that reason, star appears flickering. Star appears flickering. So star appears twinkling. So, but here you can see, so here the position of the star appears here. The position of the star appears here. So this is the position of the star. Because of the atmospheric refraction, the star appears here. Actually, the position is here only because of the many refractions. Because of the many refractions. Because of the many refraction. Because of many refractions. So what happens? So keep on the star is twinkling. Keep on the star is twinkling. Keep on the star is twinkling. Okay, so when light rays coming from star to us, so many refraction takes place. That is the reason it appears to be twinkling. It appears to be twinkling. It appears to be twinkling. Is it clear? Is it clear? And the position of the star is actually here. The position, but it appears here. It appears here. It appears here. Okay, so that is the reason. Because of the atmospheric refraction, the star appears twinkling. Because of the atmospheric refraction, the stars appear twinkling. And the sun rises, so advanced sunrise and delayed sunset also. Advanced sunrise and delayed sunset also the same. Advanced sunrise and delayed sunset. So I'm taking the earth here. Okay, atmosphere. This is the earth. This is the earth. And this I am taking the atmosphere. Okay, so atmosphere. So this is the origin. I am taking this origin. Below this one, here is the sun. I am taking the sun here. Okay, sun I am considering sun. Okay, from here, if the light rays are coming, so until this position, it will be normal only. Until here, it will be normal. Whenever the light ray enters into the atmosphere, so the bending of the light ray takes place. When you are seeing here, when from here, if you are seeing, okay, the sun appears, the star appears here. Okay, the position of the star, the position of the sun. So sun is a star, right? So we can see. So the position of the sun appears here. Here. So this is the apparent position of the sun. So here, if the light ray is coming from sun, the sun. So because of the atmosphere of the earth, so this entire portion is atmosphere. Okay, so atmosphere. So because of the atmosphere, the refraction takes place. So that is the reason. This is the origin. So I'm taking this origin. I'm considering. So because of the atmosphere, refraction takes place. So it appears above the origin. So the sun appears above the origin due to atmospheric refraction. The sun appears above the origin. So this is the reason. So the sun appears 2 minutes early. 2 minutes advance sunrise. So yeah, actually the sun is here only because of the atmosphere. So refraction of the light takes place. The sun appears here. So 2 minutes before only. Actual position is here only, but the apparent position is here. So this is actual position of the sun. Actual position of the sun. And this apparent position of the sun. Apparent position of the sun. Okay, now. So this actual position. So when light ray is coming from the sun, because of the atmosphere, the refraction takes place. So it appears above the origin. 2 minutes before only it will appears. 2 minutes before only it appears. That is called advanced sunrise. Evening time also, still it will goes down, sundown, but still it appears. So delayed sunset, advanced sunrise and delayed sunset. Very important for 3 marks question. Very important for 3 marks question. So very important. Make sure that you are learning. So from the sun, light rays will come. So after refraction, the sun appears above the origin. Advanced sunrise, and delayed sunset. So before 2 minutes only it appears, and after 2 minutes also, after sundown also she'll appear. So that is the reason advanced sunrise and delayed sunset. Advanced sunrise and delayed sunset. Next one, we are going to the related to position. I will tell one small logic related to position, that is atmospheric refraction. So next topic is related to colors is scattering of light. Scattering of light. So I'll explain the scattering of light in depth. So just listen carefully. So when the light is coming from the sun, if the light is coming from the object or sun, if you take, so if it is falls on the particle, if the falls on the particle, okay, I will explain about first wavelength. I will explain wavelength. I will explain. So I'm considering here. Now I'm taking like this. Now I'm taking like this. Now I'm considering like this. Okay. So here. So this is the wavelength of the light. The wavelength of light is nothing but the distance between two consecutive crusts. The distance between two consecutive crusts or two consecutive troughs. The distance between two consecutive crusts or two consecutive troughs. So if you are taking, that is called wavelength. The distance between two consecutive crusts or two consecutive troughs is called wavelength. Wavelength. So whenever the light incidenting on the particle, whenever the light rays is coming like this, it is incidenting on the particle. Whenever the light ray is coming and incidenting on the particle, so the size of the particle, is comparable to the wavelength of the light. The size of the particle is comparable to the wavelength of the light. So here you can see the size of the particle is comparable to the wavelength of the light. So once again, the size of the particle, whatever the light ray is coming, okay, so if the light ray is like this, so this wavelength is comparable to the size of the particle. Size of the particle, and this is a light ray which is incidenting on it. So whenever the light ray is coming and falling on the particle, if the size of the particle is comparable to the wavelength of the light, then this particle will absorb the light. This particle will absorb the light. Like best example, if you take the sponge and immerse in the water, what happens? So sponge will absorb the water. So like that. So whenever the light ray falls on the particle, the size of the particle is comparable to the wavelength of the light. Then the particle will absorb the light and re-emits in all directions with a different intensity. So if you are taking this particle, when light falls on it, so this particle will emit the light in different direction with a different intensity. So this is a particle. So we can take atom or a molecule also. We can take atom. So atom. Okay. So whenever the light ray incident on the particle, so after observe, see, as I said, this condition is satisfied. If this condition is satisfied, the size of the particle is comparable to the wavelength of the light. If the size of the particle is comparable to the wavelength of the light, the particle re-emits the light in different directions. So this is the light. So this also light. Okay. So light in different directions with a different intensity. So particle will re-emit the light in different directions with a different intensity only when the condition is satisfied. Whatever the light incidenting on the particle will absorb the light when the size of the particle is comparable to the wavelength of the light incident on it. Then what happens? That light ray will scatter in all directions. With a different intensity. So this is known as scattering of light. So scattering of light. Okay, so blue color of the sky, reddish color of the sky. Evening and morning, you can see sky appears reddish color. Even sometimes it appears blue color, because the particle present in the atmosphere will scatter the blue light most, because blue color has shorter wavelength, red color has longer wavelength. Danger color is in a red color. danger color in red color. So we can see whenever the light incident on it, danger color is in red color, danger color. So you can see whenever the light incident on it, red color has longer wavelength. You can see the danger signals are in red color because it has longer wavelength. Through the smoke, it is least scattered, least deviated, least scattered. So that is the reason even for far distance also we can able to see. So here, if you are taking that, here, so okay, during evening time or morning time, whenever the light rays comes from the, whenever the light rays is coming, okay, so I'm considering here, I'm considering like this. I'm considering like this. Okay. So here you can see. Here you can see. Here you can see. Now I'm considering now. I'm considering this point. So if you are taking the earth here, this is the atmosphere. Here is the sun. I'm taking. If the light ray is coming from the sun, so this distance is more compared to the remaining distance. So whenever the light rays incident, because of the atmosphere present, all the colors will scatter away. Only red color will travel long distance. Even in the evening time also. So red color will travel long distance. So that is the reason it appears reddish color. So remaining time, what are the particles are present here? What are the particles are present in the atmosphere? So blue light. So the particle size is comparable to the blue light. That is the reason. So it scatters. The blue light scatters the most. That's why we can able to see the blue color. Sky appears blue color. Sometimes, so here you can see in the noon time it appears white. Why? What are the particles here? What are the particles are here? So okay, those particles are equally scattered all the colors in all directions. That's why all the colors will be mixed. Again, it will comes as a white light. You can see the Newton disk. So here all colors you will place red, while Ibgia colors, violet, indigo, blue, green, yellow, orange and red, all colors. If you rotate it, it becomes white. It appears as a white color because all colors will be mixed. Here also, what are the particles are present here? What are the particles are present in the clouds? Whenever the light rays comes from the sun, immediately those particles will scatter the light in all directions with the different end. Anyway, equally light will be scattered. Those all colors will be mixed. So we'll get as a white light. So we'll get a white color in the noon time. Remaining time blue color. And deep sea appears blue color. Because of the scattering of light. Related to colors, it is scattering of light. Related to positions, it is atmospheric refraction. Related to colors, it is scattering of light. Related to position, it is atmospheric refraction. So I hope it is very clear. Next one, we are going to the next one. Okay. So next one we are coming. So that is about scattering of Tyndall effect. The path of the light so becomes visible when it is passes through Vinay High. So the path of the light becomes visible when it is passing through the colloidal solution. If you are taking the beaker, colloidal particles are there. When light passes through it, so scattering of light takes place because of the particle. You can observe. You can take any color and you send the red color. You can send the laser light. So at this path. At the path, thank you so much. At the path, so you can appear. See, if you send the laser light, okay. So at this position, from here to here, the path appears very clear. So, but the path appears very clear. Because so scattering of light takes place by the colloidal particles. Scattering of light takes place by the colloidal particles, colloidal solution. That's why at this position, so the path of the light becomes visible. So when the light passes through the colloidal solution, So scattering of light takes place a colloidal solution. Then path of the light becomes visible. Path of the light becomes visible. That this phenomenon is called Tyndall effect. So the path of the light becomes visible when it is passes through colloidal solution. So this phenomena is known as Tyndall effect. You can see the whenever you in the morning time when you open the door, when you open the window, so a narrow beam of light, like a beam of sunlight. So the dust particles appears to be no, the dust particles appears in that sun. Okay, so the dust particles are flying, and you can see one more during rainy time near the bulb also. During rainy time near the bulb also, you see that appears watery. And one more thing, a color also we can see very clearly. The particles, the rain particles will fly, we can able to see. Even the dense forest also narrow beam. Even in the sunny time when you in the trees, in middle of the tree, a narrow beam of sunlight will fall. So there also we can able to see the dust particles are flying. So this all because of Tyndall effect. So the path of the light becomes visible when it is passing through the colloidal solution. When it is passing through the colloidal solution. So this is about Tyndall effect. This is about Tyndall effect. This is about Tyndall effect. Okay, ma. So I'll start 12th grade. Already 11th grade it's going. So at 6 p.m. every day 6 p.m. For grade 11 I'm teaching. Grade 11 I'm teaching. So you can join at grade 12 also. I'll teach those topics. I'll fix the timing because of the timings. I couldn't able to teach. So definitely I will adjust the timings and I'll teach the concepts. Okay, so this is about human eye and colorful world. Completely I explained from starting to ending. So few questions are there. Those questions we'll discuss. So if you like this video, so do like, share and subscribe to Student the Brand. If you like this content, you can share with your friends. So you can contact this number 984981280 984981280. You can contact this number. I will discuss remaining details. So those who need classes 1-to-1 or like that, or not only physics, remaining subject, if you want, you can contact this number 984981280. So this is about human and colorful world. So if you like this video, please do like, share and subscribe to Student the Brand. You'll get updates, you'll get latest updates are like that. Okay, thank you so much for joining and attending and listening the class. So thank you so much, we'll see you soon.